Right.
Sure, Donald. That's pretty funny. Happy Tuesday, lies.
I'm not happy.
You have been disconnected.
Okay.
You know, sick of hum of the room. Who would just like to skip the meeting and have a nap? We don't seem to have an AD in the room, so
We have an AD.
Oh, we do. Oh, see. Sorry, Martin.
Well, I guess. Yeah. Hi, everybody. Hi, everybody. I guess you need to be close to this microphone. So this is the Babel Working Group meeting. I'm Donald Eastlake with Huawei, and co-chair is Russ White. There's all kinds of complicated flowcharts and signs on this table.
This is called loading your presentation. Those are just the instructions for loading your presentation on October.
We're musing over this wonderful sign on the desk up here prepared by the Secretariat. Which is interesting. Anyway. And let's see, our AD, Martin, is here in the room. Let's see here.
There's too many computers on.
Yeah, there. So.
No, well, everyone read this. There will be a test at the end of the working group meeting. No, well, there will be a test at the end of the working group meeting, so read this well. There's the agenda.
Sorry for the vertical instability of the slides. So, document reviews are good. improves quality, helps get documents to progress. So if you would like your document reviewed, probably good to review other documents and things like that. Here is the proposed agenda. There's administrative stuff. We do have volunteers for Jabber and Minutes, which is great. Anybody suggesting changes, we can bash the agenda a bit. We go over the status and milestones and things. Presentations on HMAC and Babel, DTLS, Babel Security and HomeNet, Babel Information Model, and I want to have a brief look at the possible revisions to the milestones, because our milestones are kind of out of date. And then wrap things up. So we actually have a bigger room and more time than we needed or asked for, I think. So anybody want to change the agenda, add or delete or whatever? I guess not. So in our status, we had a charter update, a small change done at our request, the working group, by the IESG, which basically decouples the requirement to produce a Yang model from getting the standards track based protocol out. And so we can do the Yang model later. And it doesn't affect the information model, which is moving along and in pretty good shape. We have a presentation on that also. And with that information model, it should make it easier to produce the Yang model. There is not anybody working on it right now that I'm aware of, the Yang model, but it's still desirable. So we have 4 working group drafts currently, and a number of these have been sort of sitting in working group last call for a while, just really because there didn't seem to be a lot of response. There hasn't been any negative response, and has been positive response, but not a lot. And particularly the applicability draft is pretty short and simple. So I'm wondering if we can, at least for the applicability draft, I can ask if there's any objections to us declaring that to have working group consensus based on the response on the mailing list. Is anybody here or on the MeetEcho have any objections to doing that for the applicability draft? Sure. I was going to, and asking if anybody here or in the room or on MeetEcho has any objection to declaring working group consensus for the applicability draft. The answer would appear to be that no, there is no such objection, and that there is support on the mailing list, and it's been discussed on the mailing list and presented in previous meetings. So I think chairs are just going to declare consensus for the applicability draft. I don't know. The other 2 are more substantial. I don't know if you want to.
No, not really.
Okay. For the other 2, we'll continue them in the working group last call status. People should respond and comment. More positive responses will be good. And it's perhaps even more important if there are people who are opposed, they should speak up too and say why they have a problem with the RFC 6126 BIS draft or the source specific draft.
I mean, having positive responses to this draft is ready to go or whatever on the working group mailing list is very helpful, actually, not just no response.
We did have a working group last call on RFC 7298 BIS, which had opposition and was declared to have failed working group last call. And there's sort of it's an HMAC-based authentication one. We do have an alternative draft now. So the there's a HomeNet draft on Babel profile. Yes.
Sorry, clarification from Julius. There was an adoption call, not a working group last call for 7298 BIS.
You're right. Excuse me. Yeah, that's a good correction. It's not draft IETF. It's draft of Senko, and it was an adoption call, which is different, and it failed to get consensus to adopt. There's the people may be interested in the HomeNet working group draft on the Babel profile for HomeNet, and the last three documents here are the earlier experimental RFCs for the Babel protocol. Let's see, this is our current milestones. So if people want to look at this, these slides, there's the ones we've completed and the ones where we're way behind. So probably the suggestion of our AD, the slide after this has some suggested milestones, which add one and change dates. So I thought we'd discuss those at the end of the meeting after we've had the various presentations, because that might affect when people think we could actually achieve these things. So I guess with that, we can go ahead with the first. Oh, that's interesting. How do you put out of this thing? Maybe do that. Okay. The HMAC and Babel presentation. Oh, that's interesting. That's too big. Yeah. Okay, I was just experimenting here to see if there's any way to. The thing is, the aspect ratios are not the same. Is the problem. So,
Julius, look beyond yourself.
Okay, well, he has to do something. There was mail for him from the Meet Echo people on how to do that. So he's done it before. I don't know. Okay. So Julius, you should be on.
Can you hear me?
Yes.
Okay, good. Is the sound okay?
Yes, it's excellent.
So hello, I'm Julius Krobacek. I'm sitting here in Paris. It's about 70 degrees centigrade in my office, and it is early afternoon. And I'd like to tell you a few words about the protocol that have been done by Clara Do and Weronika Kołodziejak during the last months, which is a security protocol using HMAC for Babel. Next, please. So I'm not the person who has done most of the work. Most of the work was done by a lot of people. So Denis Ovsienko started the whole thing. He did RFC 7298, which I'm going to say a few words about. And then he attempted to fix the flaws in 7298 by doing 7298 BIS. Then we worked together with Clara Do and Weronika Kołodziejak. Clara Do is following online, and Weronika is sitting here with me. And they did an implementation of the new protocol design based on Denis's work. And then there was input from a lot of people. So I'm afraid I'm going to forget people, but David Skenazy convinced us to use a pseudo header. Marcus Stenberg designed the index mechanism that I'm going to describe later. Tauke Heuland Jørgensen, Florian Horn, and Paul Rosière gave a lot of suggestions. Next, please. So the plan now is to have two protocols for Babel security. Now, the reason is that there is a natural tension between, on one hand, having a simple and reviewable protocol, and on the other hand, having useful features. So we want to have, on the one hand, a simple reviewable protocol, and on the other hand, a protocol with all the features you might want. So HMAC, which I'm going to speak about in this talk, uses unchanged Babel. It has no dependencies except for hashing and has absolutely minimal features. It has symmetric keying, few keys per interface. There is one feature which I think is essential and which it does have. It is key rotation. On the other hand, there is another protocol, and that's going to be David's talk, which requires some fairly significant changes to Babel, notably moving everything to unicast, which depends on DTLS. So you import all of a DTLS library with all of its features, such as asymmetric keying. You can do pairwise keying, and you have a lot of other features that you might or might not want. Next, please.
If I wanted to mention something, I think one important thing is DTLS provides encryption, right? Whereas HMAC only provides authentication. Okay.
I've missed this, you're right. So HMAC only does authenticity, while DTLS also does privacy. Next, please. So now I'm going to spend a few minutes giving you the technical details and trying to avoid getting too bogged down into the details. So if there are any cryptographers in the room, you're going to cringe, and please accept my apologies. So you all know what is an HMAC. The basic idea of HMAC is that instead of sending just a message M, you send the message concatenated with a hash of the concatenation of the message and the secret key. Now, I know that's not the correct definition. It's a little bit more complicated than that, but for this talk, this will do. And so you send this concatenation, and on the receiver side, the receiver recomputes the hash independently. And if the two hashes match, that proves, one, that the sender knows the secret key, and two, that the message has not been modified in transit. Now, HMAC does not protect against message replay. So imagine the following scenario. Bob sends an announcement. Okay, he says, okay, I can reach Google. Please go through me if you want to send to Google. And signs it correctly with an HMAC. Now, Alice receives the message from B and installs a route through Bob. C, in the meantime, Chloe has captured the message from B. And much later, when Alice has forgotten everything about the exchange, Chloe replays the announce. Alice goes, oh, well, Chloe has sent a properly signed message and installs a route through Chloe. And Chloe has gotten all the traffic to Google. Okay, game over. You've lost. That's a replay attack. Next, please. So the first mitigation for this attack is to use a pseudo header, that is to protect the sender and receiver's address in addition to the message contents. So instead of sending an HMAC that just covers the message, you send an HMAC that covers the source address, the destination address, and the message. Okay, so the bit that you've added to the hash, the concatenation of the source and destination, that's what's called the pseudo header. So here, a replay attack is still possible, but it's a little bit more difficult to exploit. So B sends an announce, okay, properly signed by HMAC. A installs a route through B. And if later C wants to replay the announce, C has to spoof B's source address, because the source address is part of the signature. And so A, in that case, can only install a route through B. So here, C didn't manage to get all the traffic, but it's still a replay attack. It's still a vulnerability. Next, please. So we need some form of replay protection, and the natural thing in order to protect against replay is to have a strictly increasing counter within all messages. So you can use a clock, you can use just a variable that you increment. So in this case, B sends its announce, signed by HMAC, but it also says, look, that's packet number 42. And A installs the route through B. Now, if later C replays the announcement, it will replay it with the packet counter being 42, because it was signed by HMAC and it cannot modify the packet without invalidating the HMAC. And A will reject the packet because the packet counter is too old. So this is a perfectly safe protocol, assuming that the sender uses strictly increasing packet counters and that the receiver keeps state about the last packet number received from every single neighbor, essentially forever. Next, please. So basically, I'm glossing over a number of details, but what I've described above is basically what 7298 does. And it has two issues. One is that it requires that every sender maintain a strictly monotonic packet counter. And the second one is that it receives that every receiver keep the packet counter history of every peer it has ever encountered, basically forever. So in 7298, there is some language about an A&M timeout, which qualifies the forever here, but it does cause some vulnerabilities. Now, both are problematic. Persistent sender state is something that can be done, but it cannot be done portably. So persistent storage, if you keep your packets counter on disk, is non-portable. Depending on which device you're on, the persistent state might be the file system, it might be some form of non-volatile RAM, and it's also not always reliable. Sometimes the persistent state will be reset, for example, if you have a disk crash. And hardware clocks don't necessarily exist in all of the routers that we use, and even when they do exist, they are sometimes reset. And if you lose your PC, for example, because you've rebooted and lost your disk, the failure mode is very unpleasant. Your node will be black holed up to, in the language of 7298, up to the A&M timeout. As to the receiver state, well, I think it's completely unrealistic because you need to keep receiver state for all the neighbors you've ever met. So that means that you have unbounded amounts of persistent storage. On this side, however, the failure mode is a little bit gentler. After loss of state, we are just vulnerable to replay, as Dennis showed us at IETF 96. Next, please. Okay, so we want to avoid persistent state. Persistent state is evil. We want to use soft state only, and that's what we do in draft-do-babel HMAC. So we have two additional mechanisms. One is a challenge mechanism, which allows you to, at any time, to create safely fresh receiver state, and the second mechanism, indices, which allows you to reset sender state at any time. Next, please. So, how does the challenge mechanism work? So, B announces sends an announce with a packet counter being 42, properly signed by HMAC. Now, A checks whether it has state about B. And if it has no state about B, then it sends a challenge. So the challenge consists simply of a nonce, a number that has never been used before, that it sends, properly signed by HMAC. And B replies with a new packet counter, 43 because 42 was the previous one, and repeats the nonce. And because the nonce is fresh, the challenge reply cannot be a replayed packet because 57 has never been used before. And when A receives the challenge reply, it can safely establish receiver state from the challenge reply. And the important property here is that A can send a new challenge at any time. The only cost of a challenge is 1 RTT. And that means that the choice of when to purge receiver state becomes an implementation detail. Next, please. Now, on the sender side, well, the packet counter is reset less often. We accept that it will only be reset when a node reboots. And the mechanism here is somewhat different. Every single packet carries not only a packet counter, but also an index. So the index is an arbitrary string of bytes. It indicates basically which copy of the integers you're working with. The idea is that whenever you reset your packet counter, you pick a new index. Now, when A detects an index mismatch, it means that B has reset its state, and therefore it needs to establish fresh state and does a challenge. And B replies with the packet counter as well as the index, which allows A to reset the data. So here again, we can generate a new index at any time. The cost is 1 RTP again. And when to purge, sender state also becomes an implementation detail. Next, please. Okay, all of this has been implemented and specified by Clara and Veronica. So the draft, it's a 0-0. It needs a little bit more work, especially when speaking about implementation considerations, but it has been shown to be good enough for implementation. It's 16 pages long, including boilerplate and appendices, and of those 16 pages, only 7 are normative. And we already have 2 independent interoperable implementations. The original implementation done by Clara and Veronica, which has been integrated in BABEL-D but not merged into the master branch yet. It consists of 793 lines of code, not counting hashing. It requires fairly minimal changes to BABEL-D. And according to the ladies, it was easier to implement than RFC 7298, which is what they implemented earlier. And there is a second implementation, which I haven't looked at yet. It's due to Toke Høyle and Jørgensen. It has been integrated in BIRD, and again, it's not merged yet. It's a little bit shorter than our implementation. It's just 533 lines of code. And Toki explained to me all this stuff in an email in which he said, I found the draft pleasant to read and straightforward to implement. Next, please. Okay, so although we already have 2 implementations and have written down the specification, we still think there are a number of open questions. All of those has been discussed on the list. So first of all, we have to decide what is the size of the nonsense index. We have to decide whether we want to use the packet trailer. And we want to pick between 2 variants of the algorithm, the explicit or the implicit indices algorithm. Next, please. So, about the size of the nonsense index. A Babel TLV can be up to 255 octets long. That means that we can encode up to 255 octets of nonce with up to 251 octets of index. So, our current thinking is that a nonce can be used to encode a cookie for DOS avoidance, and that arbitrary size nonces do not complicate implementation. On the other hand, we see no reason to allow large indices. So our proposal is that nonces can be any size, but indices can be up to 10 octets, and larger indices are silently dropped. Next, please. So the other question is, where do the HMACs live? And there are 2 possibilities. We can put them beyond the packet or within the packet. So if we store the HMACs within the packet, we have a problem because the body participates in HMAC computation and an HMAC cannot hash itself. So it requires a fairly complex dance of clearing the HMAC TLB, hashing, inserting the HMAC, and so on. Putting them in the packet trailer simplifies the implementation, but it makes the specification slightly more complex because we have to specify the packet trailer. That is what we support. Next, please. And finally, there is a very sexy variant of the algorithm due to Marcus Stenberg, which consists in omitting indices in all packets except challenge replies. So Stenberg noticed that the index is usually known by the receiver. The only time at which the receiver does not know the index is when it's challenged. So the idea is to omit the packet in ordinary packets, include it in challenge replies. So that shaves off a few bytes on the wire. It's a very clever solution. However, it complicates the implementation quite a bit. First of all, you need to parse the whole packet before you can compute HMAC. Second, the encoding the various TLVs is much more complex. And finally, it's a clever solution, which makes it more difficult to prove correct. So I've done my best to describe this variant of the algorithm in Appendix C of the draft. Please check. Next, please. Okay, so I think we have a simple, easily implementable cryptographic authenticity extension for Babel. The specification is simple. The implementation is very doable, and we already have 2 independent interoperable implementations. There are some open issues that need discussion and thought, and I hereby ask the working group for adoption of draft though Babel HMAC. Thank you for your attention.
Thank you. Are there questions and comments?
David Skenazy, Apple. Could you go back a few slides to, let's see, keep going. Yep. Slide 10, please. One more.
Okay.
Just because I received a question unicast to clarify for the room. If the packet counter wraps, meaning it hits the limit of how many bits we have, the sender must generate a new index, and this is the property that prevents replay attacks for that.
Yes, or it can rekey. So the property is that the same index PC key triple is never used twice. So when you run out of PCs, you have to either generate a new index or a new secret key.
Yep, thank you. For the open questions, I've put out an opinion on the list, but I think all these are solvable problems. And then just to your last question, I really like this document, and I think it is ready for adoption.
Okay. Any other comments or questions? I guess I asked if there's any objections to adopting it here or on the out in Meet Echo land. I guess not, but we'll do a confirmation on the mailing list, and see what happens. Okay.
We have one per Christopher Wood on the Jabber in favor of adoption.
Yep. Okay, thanks. Since you've spoken it at the mic, that'll get in the minutes, and we'll have a record of it. There was a Jabber support. Oops. Okay. Babel over DTLS. Do you want a laser pointer? Okay.
There we go. Sure. All right. Does it click? Perfect.
It does.
Yeah. All right. Good morning, everyone. My name is David Skenazy, and I'm going to be presenting Babel over DTLS. So I, like Julius was saying in the previous presentation, I didn't do most of the work on this either. Most of it was Antonin with help from Julius. So I'm just here to present because unfortunately they couldn't be in the room today. So Julius already kind of discussed the motivation for this earlier. We need a way to secure this, and having multiple security models for different use cases is very valuable. So for cases where you want simplicity, Babel HMAC is great. But if you have deployments where your keying model is more complicated, say you want a public-private key pair for each device, then HMAC doesn't quite cut it. For anything complicated like that, we don't want to be reinventing security in this working group, so we just leverage DTLS. So how does it work? The key there is that it leverages Babel over unicast. So Julius calls that a change to the protocol. I don't really, because my implementation of Babel does everything over unicast in the first place. But running Babel over unicast fits the standards. It is just a requirement if you're doing DTLS, because they're pairwise encrypted keys. You can't multicast those packets. And then you send multicast in the clear. Mainly you send hellos to discover who you want to talk to. And then as soon as you discover someone, you perform DTLS, and then everything is encrypted. All unicast traffic is encrypted there. The way you decide who is DTLS client and who is server is just by looking at the low bits of the linked local address. And then you must drop any TLV that you receive unencrypted other than hello and I heard you. And that's about it for how it works. Similar, very small open question that we need to resolve at some point. Unencrypted I heard you, right now they're allowed. They're not absolutely necessary, so we could decide to drop those as well. Another question, which is one that Julius and I disagree on, and Altona hasn't made a very clear statement yet, is the port numbers. So we have two ways to do this. One is everything on the same port. So let's take a step back. Babel, regular Babel is a peer-to-peer protocol where everything is sent and on port 6696. And I mean both the UDP source and destination ports are both set to 6696. Doing DTLS for that is kind of weird because you can end up having multiple DTLS connections on the same 5-tuple, and then it makes the DTLS implementation a little bit more complicated because it needs to be able to differentiate those. The subtlety there is if you have a connection established and that node reboots, you get a new client hello, you should renegotiate with that, not necessarily drop it. But since the client hello is not authenticated in any way, that client hello could be an attack for someone else. So you don't want to clear your state on receiving a client hello. So you need to kind of keep both states on the same ports at the same time, which is doable, but complicates the DTLS implementation. And another downside is some DTLS stacks handle like their underlying networking directly, meaning they open their UDP sockets. And if they won't let you create multiple connections on the same ports because then they don't know which one to send the packets on. So that's something you also need to handle in your implementation. The other approach is to use separate ports. So that's what HNCP over in HomeNet did, for example, where you have a regular port for the unencrypted traffic. You ask IANA to define another port for the encrypted traffic. So that would be for Babel over DTLS. And then anytime you send a packet, the server's on that port and the client uses an ephemeral port. And that's kind of the standard way of how DTLS is used. The downside that Julius brought up is that it can cause packet reordering in that all the multicast packets are still ordered and all the unicast packets are still ordered, but they can be reordered between them. Given that things like the sequence number for hellos is separate for unicast and multicast hellos, I don't particularly see that as a problem. The other downside of this approach is that if you have a network where you're running Babel that has a firewall between the routers that you've opened port 6696 for on, you need to open whatever the new port is. Before I move on, does anyone want to comment on this, either in the room or in the virtual room?
Barbara Stark. I see the firewall thing as being irrelevant. I'm really, really used to things that do DTLS and TLS having two ports, one for the unencrypted and one for the encrypted. And so personally, just because it makes my head spin thinking about using the same port for both, I'd really prefer to have separate ports.
Thanks.
Ted Lemon. I think it would be interesting to try and articulate a use case for when you'd be doing Babel with DTLS through a firewall, but maybe there is one. If there is, then, you know, that's just the price of doing business. You know, you set up a firewall, you need to deal with the issues. And by the way, the thing's not going to work until you open up the firewall, so you'll figure it out. I don't think it's an issue.
Oh, and another point is if you use on the same port, then you need to, when a packet comes in, figure out if it's DTLS or not. It does happen that the first byte of a Babel packet is 42 because Julius still can't get over that number. And the first byte of a DTLS packet is the TLS type, and 42 is not currently assigned. I don't personally want to go to the TLS working group and ask them to reserve a code for Babel, especially number 42. Some people might like it. I think we have someone in the virtual queue.
You do. Go ahead, Dennis.
Hello, do you hear me?
Yes.
We can hear you.
I wanted to make sure if you use two ports, have you considered such a possibility that you have a pair of speakers using two exchanges on different ports, and then another pair of speakers doing another exchange on another pair of ports, and then somebody just crosses over and uses DTLS exchange between one pair and substitutes the actual routing protocol exchange from the other. Have you considered if such an attack is possible, or?
Yes. So what DTLS does is that as soon as you finish your handshake, you have an ephemeral shared secret that you use to encrypt all the traffic. If you grab one and switch them, it'll fail to decrypt and the packet will be dropped. So that's one of the security properties that DTLS provides.
Okay, thank you. I am satisfied with the answer.
Thanks. All right, any other comments? Anything on the Jabber, perhaps? All right, moving on. Implementations of Babel over DTLS. The first one was made by Antonin in BabelD. I made an independent re-implementation as well. We haven't found the time to do interop testing yet. I kind of want us to figure out the port question first, but I'm sure we won't have many problems. It's pretty straightforward to implement, as long as you have a DTLS stack, obviously. And next steps. So this work was already presented by Antonin at the last IETF. Since then, we have, or he has, and I've written a draft. Show of hands in the room. Who has read the draft? All right, not quite yet, huh? We would like to ask working group adoption. I suspect that will require more people reading it, but...
Hello, it's me again. I had actually read the draft when it was 8 pages long, and I thought it was better not to discuss it because, well, it was too short to discuss. But there is a question regarding the high-level approach that I had raised on the mailing list, and it's as simple as when a DTLS implementation has, for instance, 100 or 200 routers on a single segment, and they try to do DTLS. Can you quickly calculate how many DTLS sessions it does involve?
So you have a DTLS session between each pair of devices on the same link, yes.
And how many that would be?
Well, squared, yes.
And okay, for 200 routers, it would be how many?
That'll be about 90. That'll be about 19,000 sessions.
Okay.
Thank you.
And do you think it may cause any problems in real life, in real networks?
So remember, the goal of this is not to completely replace all Babel deployments with Babel over DTLS. I think if you have a deployment where you have that many routers, then probably HMAC is a better solution for you.
The matter is, I'm not discussing the use case of an internet exchange, okay, but the use case of a mesh network. And in a mesh network, each node has to be a router or a router. And it is quite possible that when mobile nodes get together, that they actually will see each other and try to establish a DTLS association between each other. And that's how I see it's possible the mesh network just shuts down. And I had raised it on the mailing list, and I think it's important to understand how far this approach can go. And at least somebody, maybe the document authors, or hopefully maybe somebody else, they could explain the limitations to.
So I think that's a good point. Thanks for raising it, Dennis. So I think it means that we need to add some applicability text to the DTLS document, where if you have a very high number of nodes and the quadratic number of pairwise connections is just too much state, then DTLS is not for you. I think that's very fair, and clarifying that can help.
All right. The matter is, it's not the first time, maybe second, maybe I did raise this point before on the mailing list, and I suggest to write it down somewhere so that the quality of the
well, add something to the draft. Thank you.
So that the quality of the deliverables does not depend on myself raising this point over and over if nobody cares about it. It has to be somewhere, and somebody has to address it eventually.
Well,
Yes,
In
we'll
one
add it to the
or
draft.
another
Thank
way.
you, Dennis.
yeah, there's another person in the MEDACO queue, so.
So yeah, I'd like to answer Dennis's comment here. So Babel already has quadratic behavior, like all distance vector protocols. So there is no such thing in Babel as the pseudo-node optimization that you will get in ISIS or OSPF. All you're getting here. So if your deployment model is to plug 2,000 routers into a single switch, Babel is not the right protocol. Now, the complexity of Babel is not changed by DTLS. In Babel, you have a neighbor data structure for every one of your neighbors. The number of neighbors does not change with DTLS. All you get is a slightly larger data structure for each neighbor because you have the DTLS state, but the complexity remains unchanged.
Yeah, that's actually a really good point. Thanks, Julius.
Yeah.
All right, that's it. Any last questions? Thank you, everyone.
Yeah, thanks. Let's see. I have Babel security in HomeNet. That would actually.
Just at this moment, my Etherpad. At this moment, my Etherpad is It's a beautiful thing. Service temporarily.
You can move the mic stand or take the microphone in your hand or whichever.
I will move the mic stand.
Okay.
I don't like holding too many things.
The server is temporarily unavailable, so I will take that. That's on a local.
Huh? Oh, okay. So this is going to be really, really quick. Julius told me that I had to present on Babel security stuff in HomeNet, and so this is what I'm going to be telling them. How do you fine-tune this?
I can do it. I don't know.
Yeah, maybe you should. Okay, so there should be absolutely no surprises to anybody on this slide because I'm pretty sure you just heard everything that is here. And yeah, any surprises? No. Okay, so this is slide 2, and these are the points that I was told to convey to HomeNet. They're expected to recommend one security mechanism for all Babel implementations, but independent of that, HomeNet needs to pick one that it would thinks makes sense in the context of the HomeNet use case. And they also need to, once these drafts progress, if there's any optional features that they want to make mandatory, things like that, they need to figure that out. And then the biggie is, of course, how in the world do you distribute the stupid keys and credentials? Okay, that one's done.
Okay.
Any comments? Oh.
Of course, David Skenazy, Apple. Actually, So maybe that's a question for the chairs and process. Maybe now is not the right time. When do we want to have the conversation about which security mechanism we make MTI and the one that we publish alongside the 6126 BIS document?
Well, it would seem good to have the alternatives adopted, but pretty soon.
All right, cool.
Next
Okay,
presentation.
which was orthogonal to my slides.
Yeah.
Okay. Fair enough.
And this
Okay,
is-
so I'm going to continue to stand up here and now talk about the information model. Okay, so I do have a few outstanding comments from Julius and Toke that I need to update into the information model. And this is just kind of what they were. We need to further discuss what how to describe whether we use the leftmost bit, the most significant bit, or some variation on Indianness, which personally I'm not a fan of using the term Indianness because that doesn't convey what I'm thinking of seeing, but I'm not going to go there right here because I don't think that's an important discussion for us to have here. Then there was a thing about the unicast hellos and things and representing them in the data model, and I think Toke and Julius are absolutely right, of course. And so I'm just going to do what they tell me there. And then there's this IHU interval discussion that we've been having, and we're clearly not communicating very well on that. And so I'm going to continue that one on the list. And let's see. Then comes this next hop address, and I'm going to have to, once Toke gets off his canoe, better understand what he's talking about there. And so that's a pretty short list, and that's good, and they're all minor. I don't think anybody's going to hurt anybody over these things. And so let's see. These are some of the issues, and most of the...
we shouldn't.
Yeah, you do it.
We shouldn't both try to address at the same time. Okay.
Okay. I've kind of just, as we go along, people say, well, what about this? And so I try to record a lot of those what about this things at the end, and I've just compiled a whole bunch of what about this things that, people may or may not agree with the decisions I've made. And so I've just sort of here recorded some of the decisions I've made on these. And I'd like to see if anybody has any heartburn over the decisions I've made on any of these, because I'm thinking in my next draft, I'm going to just close all these issues if nobody has anything to say on them. So let's see. I think we actually, fixed the interfaces object stuff, and Julius hasn't complained in a while. So I think we're actually fine on number 1. And unless Julius complains, I'm going to move number 1 to the closed state. And then statistics and logs. There had been some initial discussion about statistics and logging, and I included a few logs, specifically a log about attempts to use security pairing. That is, when you see a new device, to kind of do a bit of logging that you see something new and it says that it's okay, but that way if you ever have any questions as a user and you're going through the log, which we all do all the time. And then I think I've got another log on you can optionally log your hello messages. And that's the entire extent of logging, and I'm not doing any statistics. Okay, so then comes number 3, parameters for security anomalies, and that's where I think the log that I defined should hopefully be okay. Just look at some of the security related messages that come through. And people may want to look at those logs to see if what I've defined for logging is good enough. But anyway, then comes the basic security model, which is really just about managing credentials and having a log. I really don't see anything else to model in the area of security other than maintaining a log and maintaining credentials. Next slide, please. Oh, wait, we have a taker.
Okay.
Hi, Mahesh.
Mahesh Zorint Corporation. So the question of security parameters, are you have you looked at any of the not from an I know that, sorry, this is an information model, but I'm sure in terms of trying to collect security parameters, have you looked at any of the other so-called data models that have defined security parameters, whether it is from a certificate or user validity information that you could probably need as part of Babel? I don't know. I'm new in that sense, so.
So I've done some TR-181 and broadband forum data models, and this is kind of similar to what we try to model there.
Okay. All right. I'll take a look at it. Thanks.
Okay. And then the last slide, and by the way, since Mahesh is here and he came to the mic, we had a chat the other day. Mahesh happens to be chair of NetConf. And so I might have talked him into trying to do a Yang model. If so, we'll see. No commitment. Okay, so the number 5, the external cost, it's just a parameter there. It's really ill-defined. At this point, I'm thinking we just leave it there in case somebody wants to do something experimental with it, and it's totally optional. Then the Babel Hello multicast. Okay, so there was this discussion that there's this optional to implement log of received messages, which Julius in his Babel D thing created of just this 16-bit of where each bit represents a hello message that was or was not received. And he's got that in 16 bits. And so I kind of modeled that because I thought if others might choose to implement that, since he does describe that in his appendix, that it would be kind of cool to at least be able to report it. Well, it's kind of a good thing to be able to report it if you implement it. So we do have that, and I think the discussion on that was that fine, it's optional. Let's see, the transmission cost, receiving cost, I have it as integers, even though 6126 bis says that they don't have to be integers, and unless somebody insists otherwise, I don't know what the heck they are, so I'm leaving them as integers. Should Babel link types have an IANA registry? Right now, none is defined, and none will be defined unless somebody says they need to be defined. And then for the security log, should it also log whether the credentials were considered okay? Right now, it doesn't, and I think that's okay, because if you log out, anyway, that's what I said. Anybody have anything, or was this just like, whoo, yeah, too much? Okay.
Martin Vigois, one question from a completely clueless person. Why don't you need an IANA registry?
Because we only have, well, 3 types right now.
Does it hurt to have one?
IANA registries are always painful, Martin.
I think they're
yeah,
fun.
but not having registries can also become painful in the future. I don't know.
What do others think? Yo, Julius, you brought this up.
This is Donald. I think that IANA registries are fun.
Hello.
Oh, yeah.
Do you hear me?
Yeah, Dennis, go ahead.
If you were looking for opinions, my educated guess would be a registry is not required, because the amount of work you have to put into the protocol to handle a new link type is much bigger than the cost of adding another type. That's just my guess. If you wanted to consider it, I would say the registry wouldn't be worth the time you spend establishing and maintaining it. That's it.
Thank you. Just a comment. It doesn't take any time nor any effort to maintain a registry.
And what does Julius have to say? Oh, good. They've got him on mute.
Is that better? Okay.
Yes.
So I rather like Babel. And one of the reasons why I think Babel is pretty cool is that it's a great platform for experimenting with various link quality estimation algorithms. So if you're using OSPF or ISIS, which are great routing protocols, you have to be very careful about what you do with your metrics and what you do with your link quality. With Babel, you just can go ahead and experiment with everything. It will still interoperate and still remain loop-free. So I believe that people will want to implement various experimental link types, and I'm afraid that an IANA registry for this would prevent experimentation. So I'd like to keep this as a human readable free-form text field rather than something that is controlled by a registry.
Well, I don't think that having a registry precludes them being readable. I was certainly envisioning the registry as having readable strings, kind of like service types. But
I would agree with that. Yeah.
I was more meaning that if somebody wants to experiment with something else, he can just put in any string that describes the actual algorithm.
Well, this is Donald. You can have registry entries that say reserved for experimentation.
Mm-hmm. That's right. That's a good point.
I think Dennis wants to speak, I think. Dennis?
I had just realized afterwards on what my educated guess is based. The link types, they do not appear in protocol encoding, and that makes difference. When it is on the wire, you need a registry. When it is not, then effectively, if the link type never leaves the space of the speaker, then it is very unlikely that a registry will make any difference. I think I had read about it somewhere, but I do not remember. But that's what my guess is based on, that fact. It does not appear on the wire.
Correct.
David Skenazy, Apple. In an interesting turn of events, I think I agree with everything everyone has said so far, which is strange. Because at first I was kind of pushing against I think Jules did a good job of describing the reasons against. But as long as this is a string that is just used in this model, and we say anything that starts with an underscore is for experimentation, you can go nuts there, and other ones we have a registry, then that sounds like a solution that would work for everyone. If Donald manages or someone manages the registry, because apparently they're fun and easy.
Okay. Then I will actually look into writing up some registry stuff for link types.
I can help if you need it.
Which brings, and I'll put it in this draft rather than in any other, because it's really referring to the information model. Okay, so I think then I just have the one slide left. So I'm going to produce an updated revision that deals with everything mentioned in these slides, including link type. I intend to create a TR-181 data model, and maybe someone else will create a Yang model if they're really nice. And then after I've made sure that I can create a TR-181 data model, I would like to ask to start WGLC.
Okay, well, sounds like a good course of a good plan. Yeah. Yeah.
Okay, anything else? And yeah, again, thank you to Toke and Julius for both kind of implementing these information model elements in their implementations.
Okay, so I proposed initially that after the presentations, we would look at these revised milestones here. So the first three are ones we've already done. So this basically proposes that we get the applicability draft submitted to the IESG next month. But since we just determined a working group consensus to advance it, I think that can be done. Gives a little bit longer for submitting the base protocol draft because of the possible interactions with security and so forth. And source specific is kind of timed the same. And then management is put further out, maybe further than necessary. I don't know. So I have welcome discussion or comments here. I'll post this to the mailing list for people to comment there. Are there comments here?
Martin Vigon speaking. Donald, since I don't know the milestones by heart, did you just change the dates, or did you change the descriptions, or you added one? No,
I added one, and I changed the dates for these three. I believe I have to go double check, but I think that's what I did. So these are already existed for the management based protocol draft and applicability. So I changed the dates for those, and they're the first three, and actually there are these two and the last one, and then I added the source specific one.
Okay. Don't hesitate as a working group to add additional milestones that would fit in the current charter if you feel you have the energy and the willingness to work on these topics. Okay. And since we are looking not more than a year ahead, you might start thinking about what to do after July 2019.
Okay.
So the July 2019, that's the management thing I've been writing. Is that what you're thinking?
Maybe it's not very clear because maybe there should be two of them, two milestones. So that's a very reasonable comment. This is the fuzzy management draft as opposed to the specific one you're writing or the specific Yang one.
Okay, because I'm hoping that the information model will be a lot sooner than July of next year.
Yes.
Okay.
Matter of fact, I'll split that into two, and for the version to post on the mailing list. It's any further comments? No. Well, I guess that is the end of the agenda. So
we have 5 minutes to wrap up, so we have to sit here for 5 minutes.
Let's see. So actually, I think we kept on schedule pretty well, and so we were given considerably more time than we asked for, and it looks like we did go over what I originally asked for, but then again, I was being very relaxed because we had all this time. So unless any topic anybody else wants to bring up, I guess we'll see you all on the mailing list and in Bangkok in November.
And thanks to Gabrielle for helping with the minutes.
Yeah. The blue sheet's out there somewhere. Yeah.
Take up extras. Everyone signed their names 15 times.
Julius thanks the chairs from Jabber.